So first of all, this is my topic is called Pedal to the Metal, but this is more kind of like a sequel actually, because I already kind of like gave a talk around this topic before, but this is actually the aftermath. So it's what happened after I gave that previous talk before. And the very interesting thing is that Metal is a low-level overhead hardware accelerated for 3D graphics, and is not what we're going to be talking about. So yeah, sorry about misleading you with that. I actually thought that it was a very clever name. It's like, yeah, pedal to the metal, you know, like the expression going super fast, until people started approaching me. It's like, oh, you're going to talk about the metal framework. Oh, no, I'm not. So yeah, sorry about that. But also, I told you before that this is kind of like a sequel, right? So, I mean, when you are watching a movie or something like that, usually you need to have context, right? When you're watching like a sequel, you need to know what happened originally. Take, for example, Star Wars, or not. Bad example, you can just watch the original 3 and that will be fine. But for this talk, though, I will actually have to give you a little bit more context in order to grasp the whole idea of the talk. So first of all, I would like to just begin the talk with a few disclaimers. First of all, this is not going to be a very technical talk. I mean, you know, it's like very early in the morning, it's the first talk of the second day, you're probably tired, you just got your first coffee. So this is going to be more kind of like story. I'm going to try to take you on the journey that we took when we were actually improving our application. Second of all, this is not going to be a recipe. It's not like I'm going to give you a list of things that you need to go back home and try, and that will actually help you launch your application super fast. And three, even though this is not going to be a recipe or a technical talk, this will maybe give you an idea of certain things that you could explore into your applications that will probably help you to improve your app. There will be some caveats though that we'll discuss later. So before I can get to the the whole body of the talk, I need to give you a little bit more context. So what is SoundCloud? So SoundCloud, for all of you that don't know it, is a media streaming service where you can actually play and music, podcasts, and many other different audio resources, right? So you can actually imagine how it is very important for us that users kind of like get to the content really quickly, because the average duration of a session for a user on the app is probably a minute, even less. They just like to open the application, get to the song, hit play, go to the background, and they're done with our application, right? Now, what I do in SoundCloud is I work at a team that's called Core Clients, and what we do is basically we're kind of like the glue in between all of the clients that we have, namely the iOS, Android, and web clients. So we're a very cross-platform team, and we get to learn and play with a lot of different things. So it's really cool team to be part of, and that's kind of like why we were actually chosen to do what we had to do for this talk. Now, at SoundCloud, we have the planning phase that probably all companies have, right? But the way that we do it is like we do planning quarterly. And basically, that means that we have a certain set of bets that the company set for our quarter. And these bets kind of like usually comes either from the C-levels or it comes even from internal developers. So for example, let's say that we decided that we wanted to, I don't know, try bug, because for example, that will actually help us reduce our compile times and it will help us a lot with the caching and all that stuff. So that could be a bet that we establish internally. But more times than not, you know, like C-level comes in, it's like, you know what, we actually want to be able to share to Instagram or stuff like that. And that's when the bets kind of like get imposed outside and we need to align with the bets of the company. So we are sitting there on our planning, and then my managers come and it's like, hey, how are you? Good morning, this is our bets, yada, 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 yada. These are the 3 main bets of the whole company, right? And the 3 main bets of the company, one of those is going to be, the main focus will be Core Clients, and it's going to be the iOS bet, which is great, right? Sounds interesting. And the bet in question was basically a teeny, small thing that we needed to do, right? we needed to improve the iOS launch times. So the iOS launch times at that time were pretty atrocious. You know, we compare against Android, and Android was kicking our butts. And that's usually not what you want to do. I mean, you never want to hear like, oh yeah, that's like the competing platform, the one that you don't like. Oh, much faster than your application. It's like, oh damn, this is not good, right? So it was like a pretty big bet. So okay, that's good. And to give you a little bit more context, I want to show you the iOS branch of core clients at a time. Yeah, that's me. Spider-Man was not part of the team, by the way. So you can imagine how reducing the launch time of an application is such a big thing for a team of one person, right? And you need to also think that it was very time limited. It was the bet for a quarter. Okay, good. So the first thing, my first instinct is, okay, what can I do to make an improvement? How can I actually improve the launch times? But, well, what is actually an improvement, right? Because we don't really know how long it's taking right now. So, I don't know, maybe the app is taking 3 days to launch. So maybe if we can make it launch in 2 days, that is an improvement, right? So the first thing is go and open up our database, query it, grab, decide if we want to fix the median or the percentile 90, and just like sit down and realize and define what is kind of like our context. So I did that. I go to the database, I search for the average and the P90, and fortunately, 1 year ago, we decided to introduce something that we call Project Smoothie. So basically that will help us track the duration of certain tasks, how much did it take to actually launch a ViewController, how much did it take to actually launch the application. So it was, every data was there. So it was great. And I was faced with impossibility. Our numbers were insane. Nothing made kind of like matched up. We had like very, very, very huge numbers. So the first thing that I do is I just go and check the code up, and very simple, you know, right? We grab that timestamp, the first timestamp, then we grab the end timestamp, we do the diff, we multiply by 1,000, and we send the data. Now, if you're paying attention, you notice that we are grabbing the timestamp, the end timestamp, diffing, multiplying by 1,000. You can see how maybe multiplying by 1,000 was not necessarily the best idea, because the time interval is in seconds, not milliseconds. So of course, if something was taking 1 second, we were registering as like, oh, this is taking 1,000 seconds. So of course, our numbers were very huge. Okay, no big deal. We just divide by 1,000 in the report, patch the code internally, release, boom. And still, we were over 5 seconds in the median. Like, wow, can you imagine like a application that's taking like over 5 seconds to launch? This is like kind of big, right? I actually wanted to improve on the percentile 90 because, you know, I want to actually make this good for the most number of users of our application. But the numbers were very, very, very big. So we decided to settle for the average, but I wanted to kind of like know exactly where we were. So I queried for the minimum and the maximum duration of the application. And this was the maximum number of milliseconds that it was taking the app to launch according to our data. 7 million milliseconds. So for all of you paying attention, you can divide by 1,000, and that means that it was only taking 7,000 seconds to launch. Only 7,000 seconds to launch, right? So when you compare that from seconds to hours, that means that it's almost 2 hours. And of course, nobody will wait 2 hours for your application to launch. Not even your mom. Who is going to do that? It's like, oh yeah, I'm just going to launch my app and I'm going to wait here 2 hours and I'll come back later and actually use it. No. So there was obviously something going wrong, right? And we were not using a custom homemade tracking thing, right? We were relying on a third-party library, very well known by a very well-known company, so it was tested, it was proved. Certainly, most likely, the bug was not on their side, right? So it must be on our side. Although, how complicated could it be to just track start, end, and boom, that's it, right? So I fire up the application, I fire up the instruments, put a lot of signposts, and I need to give you a little bit more context. Like I told you, this is a story. So we're easing into the good stuff now. So I need to tell you or to show you how the application used to look like when we actually started tracking the information. So you can see how we have this nice, beautiful home icon as the first tab, and on top you can read that it says stream, and it's very nice. So we were basically just kind of like tracking things. It's beautiful. And some months later, marketing comes and decided that we need to try a new strategy, maybe switch to this beautiful home screen where you can see it still have the nice home icon, and on top you can read home. And the second tab is the one that we used to have before, which is called Stream, which is a very subtle difference to what we had before, but it's very big because basically the requirements change from what we have. The assumptions change, but the tracking code didn't. So basically, we were tracking from the moment that the application launched until the view did appear of that view, which is the second tab. And you can imagine that there were like users that could go on a full session without actually touching that tab. So basically, we were never actually ending our tracking. So that's why we were having 7 million seconds or stuff like that for users to launch the application. Okay, so we found kind of like one of our big bottlenecks. Now, even more context. I know this is getting excited, right? We at SoundCloud have something that is called startup operations. Basically, the startup operations are a list of things that we need to execute in order for the application to be ready to be used. That means setting up certain third-party things, I don't know, accessing the API keys, establishing connections with databases, tracking metrics, yada yada. You name it, we have it here. So the thing was that it was done way before when the circumstances were totally different. So when I was first assigned the project, I was told that this is our bottleneck. You know, the startup operations is our bottleneck. So I fire up instruments and I use this, I don't know if you've ever used it, but it's a beautiful thing that's called signpost, and you can actually just track measurement and you can signal when something begins and something ends and here and there. But it's not really important to actually read on the side of this image, just two important things to notice. One is the sequential thing, it's happening on the main thread, everything is happening sequentially. And the overall duration of this portion of the code wasn't all that big. I mean, it wasn't great, but it wasn't really all that bad. But to mention, there was a very slow ViewController. It was taking a lot of time to inflate. So basically, the way that we had it is that the startup operations used to work in a serial queue. And now I decided that, well, you know, parallelization is always good, right? Because you can execute multiple times at the same time. And sure, let's just remove the serial queue, add parallelization to the startup operations. They're easy to implement, so I just need to change the code, create it so to not be serial. It's going to be parallelize, compile, run, and crash. Of course, it couldn't be my changes, right? Because, come on, we only changed from serial to parallel. It's obviously not my changes. It were my changes. So, apparently because before we were running on a serial queue, everything was running on the main thread. And apparently, and very implicitly, and very shyly, we had the things that needed to be run on the main thread. And nobody told us. So that's fine, okay. There are certain things that need to be run on the main thread. This is okay. Add a protocol so we can actually differentiate which operations need to be run on the main thread, which can be run on the background. We can still have a parallelization, implement the protocol, separate the queues, save, compile, and profit. No, it was still crashing. Of course. Now, when you run things in parallel, you don't get a guaranteed order, right? So you just kind of like fire up things and everything starts running whenever. And that's when I decided to go and check our code. And apparently we had a lot of implicit dependencies because before we were just kind of like setting up our stack in order because everything was sequential. So basically any operation that ran before you was kind of like your implicit dependency. And the only way that we actually translated that as a requirement were on the unit test, which at least was good, but it was not all that great. So I had to go back there, explicitly say which operations needed to depend on which other, run again, change the code, discover that we had a lot of more implicit dependencies weren't even represented as unit tests, fix the things, set up some singletons, and for the sake of brevity, let's say that it took me just one try. It didn't. It took me a lot of iterations to just kind of like, oh, we have everything set, run, crash. Okay, let's go back again. What am I missing? Run, crash, and so on and so forth. So it took a lot of iterations, but finally I was able to get all of the dependencies. Everything was running great. And the code was actually running considerably faster. The application was actually launching very good, like very quickly, but still the gains didn't add up to that over 5-second thing. So remember that I told you about the ViewController? It was taking a lot to load, right? So I really quickly looked into the code, and my initial idea was, because this ViewController, what it was doing was basically saving the state in disk. Next time that you launch the app, we just read from this to like show you something really quickly, go to the web, bring the new content, and my assumption was, oh yeah, we're just piling and piling and piling data into this thing, so it's considerably exponentially increasing in size. I look at the code, and that was definitely how it was working. We're just literally overriding the contents. So what is going on? And that's when I fire up instruments. So, but I'm going to give you a little bit more context. I fire up instruments, and I realize that we have certain bits of code that are taking a lot. And now, to give you this extra bit of context, when way back then, in a galaxy far away, we didn't have codable and encodable back then, when we actually started working in what we call repositories. Repositories are just basically kind of like containers of data for us, where you can actually just tell it like, hey, give me a track, give me a playlist, give me a user, and we just figure it out and give it to you. Okay, now we started creating this before Apple gave us codable and encodable and decodable. So our group of very smart engineers in SoundCloud decided to create their own protocols that were called encodable and decodable. And they were great. It was a custom implementation. It was using generics. It was way before the beauty of KeyPad, which I think we'll learn more in a different talk later today. And it was working with mirroring. Now, for all of you that don't know what mirroring is, I'm going to give you like this awkward conversation, mirroring and you. And basically, it's not very performant. It actually relies on runtime. It needs to analyze your graphs, your objects. It's not meant to be used in production, except for very specific use cases. This was definitely not one of it. So I realized that, I don't know, for example, you grab just a object and just storing it into disk and in reading it from disk was taking a lot of time, because it had to analyze on runtime the class, get all of the properties dynamically, then write that into disk. And then when you're reading, you need to analyze the class that you're going to inflate. Read that from disk and map every single one of those properties. So it was really slow. And I decided that I was going to go in a crusade, and I was going to remove all usages of mirroring from our application. I couldn't, because it was all over the place. And the problem is that I have a time to fix the launch times, which was the main focus. So I had to kind of like accept my losses. Decided that I was just going to improve what I could for the launch times. Created a bunch of tech debt tickets that will be paying slowly when we pay our tech debt, hopefully. And then I had to basically support both implementations, because I couldn't actually get rid of the whole mirroring thing. I need to be able to have repositories that support mirroring and repositories that did not support mirroring. And it was duplication of code. But fine, I did that, and we had an improvement in our launch times. It was great. Our launch times were less than 2 seconds. So we went from 5 something to less than 2. And this is great, right? What now, though? Well, I always wanted to try. At the time, at SoundCloud, we have a lot of frameworks. We embraced the microservices approach and brought it to our application, and we have something that we call micro features. And basically, each of our, not features, but we divided like our application into multiple different frameworks. So we had a lot of dynamic frameworks, which are very slow to load. And when you see this is a flag that you can turn on your code, and it will actually speed out the amount of time that it takes before you even hit main. And as you can see, the time that it was taking for us just to hit main was 2 seconds. So that means that we were taking almost 2 seconds to launch after the first 2 seconds to just reach main. And it was pretty bad. Also, you can see that SoundCloud is only taking 182 milliseconds. So really, we're not that big of a bottleneck in there. The big bottleneck is in the while lib loading thing. Now, this is where static frameworks enter into the picture. I have read a lot about static frameworks, and they were great, and I always wanted to try it, right? I read an article from Automatic. They have like a blog post detailing how they actually did this, all the gains that they got when they switched over to static frameworks. Smiley, which is a very smart person, wrote a workaround Python thing that you can actually use as a script to generate static frameworks for your projects. And I started doing this, and I got some success and some failures, and then, I don't know, out of the blue, I decided to, let's open up the documentation. You know, it couldn't hurt, right? And that's when I learned that Xcode 9.4 supports this out of the box. So there was no need to actually patch things with LD Python scripts. So it was fine. Just scrape all of my work, go back to the drawing board. And it was just a matter of switching the macro type of each of our frameworks, and then fixing some bugs and changing the test. But it wasn't all that bad. And after that, we basically reduced our pre-main time to half a second. So you can see how it was great. It was amazing. And you might be thinking, shut up and take my money. I'm going to go back home and I'm going to do it now. Well, not so fast. I mean, static frameworks are very good, but they have their caveats. So first of all, resources and static frameworks. We are used to, I don't know, like dynamic frameworks in a way, they are kind of like their own bundle, right? So when you're loading resources, you load them from their own path. So basically, when you're loading from framework A, and you say, I don't know, like instantiate this new storyboard, that means that it will look for that storyboard inside of the module A, and that will actually try to extract the resource from there. Now, when you use static frameworks, you actually compile link during compilation time, and you actually become one single blob or one binary. And then you actually need to rethink the way that you're actually loading your resources, and you actually need to change the way that you're actually carrying over your resources with you. Why? Because basically, even though you're changing the target to be a static framework, Xcode decided to compile the resources and keep them into its own non-existent bundles that are useless. So I had to write a build phase script that basically went through all of our generated static frameworks, inside of each of them, look for resources, and carry them out to our binary. It's lovely. Now, another caveat that we have is including frameworks. Before, dynamic frameworks, you were just kind of like embed them into your frameworks folder. Now, that doesn't really work like that because you get the linking at compile time and you don't need to do this. So I had to go through each of all of the frameworks, through each of all of the tests, to each of all of our example apps, because of course we have one example app per framework because we want to get like quicker iteration times. It was a lot. It was a lot to change. We kind of like started like still paying this with pain for a few months later because we had issues with localization not being found. There are like another issue that comes with static frameworks, and it's sometimes if you don't really modify, well, at least that's been our experience. If you don't modify a public interface of certain things in a framework, sometimes Xcode doesn't pick up that as a change because you modify something internally, and that means that basically you change your code, you run, and your changes are not in the binary when you're running it on the simulator, and you're just like, why is this happening? Then you have to go back, clean out the right data, run again, and sometimes it could be slow, right? So let's start just kind of like wrapping up a little bit and to get to the takeaways. First of all, it was quite an adventure for us. It was quite fun for me. I get to play with a lot of different things. I get to suffer when I was changing the, well, when I changed the static the startup operations to be parallel, I had to open my PR and have it like open for quite a while, and there was like a lot of merge conflicts, and it's like, this is bad. But it was worst. When I actually tried to change all of our frameworks to be static frameworks, I had to open the PR and I kept it open for 2 weeks. And if you thought that merge conflicts were a thing, you have not seen this. It was horrible. It was atrocious. And eventually, I just had to like stamp my foot. It's like, okay, we're merging this, and I'll deal with everything else after this. And it was the best idea ever, and also the worst idea ever. But you know, live and learn. Also, in terms of improvements and startup operation, there's always a running battle. You're never going to win this one. You always feel like you can actually do better. I can launch this faster. The app can actually load quicker. You know, you need to kind of like pick up your battles and decide like, okay, this is good enough for now. Wait until marketing comes again. It's like, hey, we actually need to improve this. And like, okay, let's do this again. So first, the big takeaway, parallelize with care. It's a great thing, right? But it's also can lead you to hurt, lots of hurt and pain. you need to properly handle sharing resources, right? Threading is also one important issue. It's not kind of like there, but it's implicit. No, it's part of it. Implicit is not the word, actually. Implicit dependencies are bad. So try to be as explicit as possible. If something depends on something, express it in the code. Otherwise, it's going to be a whole lot of pain and problems later for you. Instruments is your friend. So use it a lot. It's amazing. You can actually do a lot of amazing things in there. You can actually dissect your application. You can actually extract or verify very quickly where your bottlenecks are. Use signposts. Signposts are great. There are like multiple talks from WWDC that tell you how to use signposts. And basically you can literally sign where you are starting to do something and where you're ending. And then you get like this graph, kind of like the traces that Esteban showed during the bug compilation times. So you can actually get to see a nice graph of each of your operations that you're tracking, where everything is actually starting and ending, and how they parallelize and where the bottleneck is. It's great. Don't use mirroring unless you really need it. And then when you realize that you really need it, think twice, because probably you don't really need it. But just keep it in mind. Static frameworks, also with care. They're great, they're amazing, but you need to kind of like change the way that you think about code. You need to change the things about how you load resources, how the code gets carried over. You need to understand the difference between linking at compile time and linking at runtime. But it's great. Yeah, like I told you before, there's like this caveat that sometimes when you modify public interfaces, that doesn't get detected or noticed by Xcode. So it could lead to slower development times because now you're paying the price up front by linking at compile time and not at runtime. But I guess it's a small price to pay for developers than for users, because in the end, users are the ones that actually end up paying for the whole thing. And I think this is like my favorite one. It's a very important one. It's assume no ill intention. And this basically means remember that devs don't write code to hurt the future maintainer. Nobody actually opens a class like, oh boy, I'm going to make this so confusing and so hard for the next people that's going to actually have to deal with this. Yeah, I mean, like, people don't go there and say, oh, Esteban is the one that gets to play with this next. Okay, so we're going to make this very horrible and complicated. No, developers don't do that. So remember that when you open a class, even though you think like, oh, why will they do this? There's no blame culture. Just think about the fact that they did the best that they could at the time with the resources and the knowledge that they have. And most likely, if they come back, they will take a look at that code and will probably change a lot of things. So don't assume ill intentions. And also, do your best to be a good citizen and don't create mess on purpose for the next person to actually maintain that. These are the links for the first one is the automatic blog post where they actually explain how to set up all the static frameworks. The second one is Smiley LD Python script. It's just for history so that you can actually learn how he was actually patching the LD thing with his Python script. It's no longer needed, but it's actually quite cool to understand how things work. And the CocoaPods 1.5.0 release notes where they actually explain that they actually support now static frameworks. Now, I just want to say thank you. You can find me on GitHub. I don't think you can actually read that, but it's basically the first three letters of my name and my last name. I am Esteban at Mastodon.technology, if you're also in Mastodon. Shameless blog, we're hiring. So if you like to learn more about SoundCloud or Berlin, just look me up. I am also open to talk about, I don't know, beer, food, whatever you want to. And as a wrap up, remember that I told you there was something related to durian, right? There's no audio though, but yeah, I liked it. See, this is me getting a second bite and everything. It was pretty good. So, thank you very much.
Thank you. There are some questions from the pigeonhole.
Oh, okay. So, let's see. So, okay, the first one says, as static frameworks increases the app executable binary, it may increase the time OS takes to launch your app, which cannot be measured. Well, technically, yes, it does increase the binary size. kind of. But the thing that is not quite true is that you can actually measure it. It's with the flag that I said, it actually will tell you how long it takes for, as soon as you touch the app, for the operating system to actually load the binary into memory before you can actually get the call to main. So you can actually try it for yourselves and see if it's worth the change for your application. I guess that there are like certain applications out there that won't really benefit that much from static frameworks. But at least in our case, because of we had a lot of different dynamic frameworks, it was good for us. Yes, this is a question. Yeah, it's important. You mentioned that we can turn on pre-main time messages in console. How do we do that? Is that an Xcode feature? Yes. It's a flag that you actually need to turn on your arguments, I think, when you're actually launching the application. It is mentioned on Automatic's blog post. Just in case you want to see it again. So here you can actually see they will show how to actually turn that flag on, and it was basically will show every time that you run your application. There's one caveat with this though. It's obviously tied to development, right? The development process. You cannot actually extract this on production. Although there is a way, and that's kind of like our next step, because right now we're kind of like measuring the time that it takes to launch the app only on developer machines, and that changes depending on how many applications you also are running on your Mac. So the next thing that we would like to add is actually to be able to track this during production time. But yeah, you can actually go there and see the flag. This load. And let's see, 1 month, I guess. Signpost-based analysis and make it part of the CI. Sorry, let me read the question. So, can you automate signpost-based analysis and make it part of CI? I don't think so. I mean, the main advantage of the signpost is that it's actually a very visual thing. Although I guess you could maybe, I don't know, maybe you would like to run it and maybe take a screenshot or something and then post it for each of those PRs. I guess that's something that you could do. We have never actually thought about it. But I guess, yeah, it wouldn't hurt. And probably, maybe you can even, yeah, extract even like the numbers and probably post and try to keep a track of if things are going bad or better or stuff like that. Yeah. Do you take into account the device CPU and storage usage when starting the app? Not really. I mean, well, yes and no. I guess it depends on the device type. Basically, now that we have the parallel operation things, it's only available if your device actually supports it. If not, it's going to behave the same as the other things. As for device storage, no, we don't really get like much control of that at the time that we're just kind of like preparing the application. We do that for other things during the life cycle, but not when we're starting the app. At that time, we don't really care that much about the device size or the amount of storage that they have. Oh, and last one, let's see. Do you guys use module maps? You wouldn't need to change your imports then. Yes, we do have one module map, one Clang module map into our main binary. Well, okay, so I think I can see what the picture, like the question is. So first, yes, we do definitely use modules. So when we import, we do add import and blah, blah, blah. So that actually works when we are linking or importing our frameworks. But the thing that I was kind of like mentioning, it was just kind of like basically based on the fact that when you try to reach for a resource on dynamic frameworks, they will try to look them and load them from the different thing. So, but yeah, we definitely use modules. So all of our imports are exactly the same. We do add import and it's exactly the same. And we use Clang modules in part of our main binary because we have like very old code that cannot be extracted because it's a lot of Objective-C dependent. But we kind of like just created a small Clang module inside of our main app, so that will give us a little bit of compilation benefits as well.
Okay, thank you, Esteban.
Thank you.